Preload clearly has a huge impact on how well a bolted joint performs, so we need a way of reliably controlling how much preload is applied to the bolt. The most common way of doing this is by controlling how much torque is applied to tighten the nut, bolt, or screw. This is normally done using a torque wrench. This method of controlling preload is used a lot because it's easy to measure torque using a torque wrench, but the problem is that it isn't very accurate, and as a result, using the torque method, you're likely to get a preload in the bolt that's only within 25% of the targeted value. This is good enough for a lot of applications, but in some cases, more accuracy is needed. Another method for controlling preload is to tighten the nut enough to bring the two mating surfaces together, and then turn it through a defined angle. The angle needed to achieve the desired preload can be calculated based on the thread pitch, the bolt length, and the material Young's modulus, or it can be determined experimentally. This is called the turn of nut method. It's easy to use, doesn't require any specialist equipment, and the rotation of the nut can be inspected, but it still only has an accuracy of around 15%. The most accurate method for controlling preload is to measure the elongation of the bolt when the torque is applied, because from there you can easily calculate the force in the bolt. In theory, the elongation can be measured using calipers before and after torquing if both ends of the bolt are accessible. But more commonly, ultrasonic measurement techniques are used to determine the elongation. Directly measuring bolt elongation allows accurate preloads to be generated to within a few percent of a target value. One of the berthing systems used on the International Space Station, the Common Berthing Mechanism, uses 16 bolts to connect and create a seal between modules on the ISS.